Hi students, so today we are going to start current electricity. So current electricity is an easy chapter if you understand the concepts. Easy to score, very important. Minimum we can expect 2 to 3 questions either for Neet as well as for JEE. So concepts are easy if you concentrate well, then if you practice, then just as some tip how to prepare for Neet or JEE or even if it is board exams. Some of the students used to tell us like I do a lot of hard work but I don't get the results. As per the hard work, might be doing lot of work, but based on the hard work I am not getting the results. Okay, I am getting marks, but based on the hard work which I am putting, I don't get the required results. So results will come, or even if success will come if you do the right thing. Hard work cannot guarantee success or results. If we are doing the right thing, then we will get results. And if we are doing our hard work on the right thing in the right way, then we get success. So first thing what we need is belief on us. Okay, we should believe that I will be able to do. I will be able to do well. I will be able to score marks. I am able to acquire good results. And if you work well in the right manner, definitely success will come. So keep away all the negative thoughts and start fresh, and make a timetable, make proper plans. You can do some long-term plans and short-term plans. Long-term plans just for a span of 2 years, what I should do. This is a long-term plan from a student's perspective. Which is your favorite course? What can be done for that? All these things you can do. Short-term plan is that starts from day-to-day basis. Early morning when you get up, take a diary, keep a diary with you, take a diary, put the date. Then list out the things which you need to do that day. Allot time for that. Make it practical. Don't put too much and you deviate from that. Don't do that. Put a plan, feasible plans, then execute it one by one. So likewise, you need to plan daily. You need to work well, work smartly. Okay, make the things easy for you. So when a teacher, when a faculty of physics, chemistry, biology, maths, whatever it may be, when they take a topic, what you need to do is study it on the same day. Study it on the same day so that it will be easy for you to grasp. If you keep it for the next day or maybe after 2 days, then you may be able to receive only 50% or 60% based on the grasping capacity. Even if your grasping power is too much, even in that case also, if you don't study on the same day, definitely you will be losing some informations. Okay, then need based study or JE based study is not knowledge based learning. It is actually skill based learning. We have to get some knowledge, that is for sure, but we need to develop a skill. What kind of skill? Problem solving skill. Okay, analysis skill. If we get a question, we should be in a position to analyze it well, then we should be able to solve it. This skill when we develop, this is going to help us in further studies and in our further job. Okay, so this skill, how we can develop? First thing is we should understand from the teacher what they are telling, what the concept is. Theoretical understanding, conceptual understanding, follow up the problems which teachers are doing. Then after that you need to revise it well, then you need to practice on your own. Take any good books of your choice, then practice well, do lot of questions so that your concepts will be very clear and strong. So on a daily basis we will have tips like this. We will work as a team and we will acquire success. Okay, so let us start to the concepts of current electricity. So current electricity, so here current, what is current? Generally there are water currents, you know, flow of water is flowing very fastly, so that is what is water current, or we can say rate of flow of water, rate of flow of water. Same way wind current is there. So here what we are going to study is electric current. Electric current. So electric current, we know we put small I or capital I, is nothing but rate of flow of charge. Electric current is nothing but a rate of flow of charge. Rate of flow of charge. So we can say I is equal to delta Q by delta T. That is, suppose if we consider a conductor, if charges are flowing through it, suppose if I take a cross section, how much charge flows through it in delta T time? Okay, so current is equal to, at a time T is equal to, for example, at a time T is equal to 3 seconds, Q2 charge has flown. At a time T is equal to 1 second, Q1 charge has flown. Then we can write Q2 minus Q1 by T2 minus T1. This is what we write as delta Q by delta T. Delta Q by delta T. Now you are going to study differentiation in your plus 2, differentiation and integration. So using differentiation and integration also we can find current, that is instantaneous current. This is average current. See, for example, current that is flowing is charge per time. This formula is also right. Now if a constant charge is coming, through this conductor, we can write I is equal to Q by T. If this charge varies, at a time T is equal to 1 second, the charge coming is Q1 coulomb. At a time T is equal to 3 seconds, the charge that is coming is Q2 coulomb. Then I average we will have to find, because it varies. Current varies from time to time. Average current, how can we find? Q2 minus Q1 by T2 minus T1, delta Q by delta T. So please note it down. Pause the screen and note it down. Now average current I is equal to Q2 minus Q1 by T2 minus T1. or we write I is equal to delta Q by delta T, average. This time duration may be for 2 seconds or 3 seconds or 1 second, a time duration. Now if this delta T is very small, if this delta T is very small, if this is very small, then we call that current as instantaneous current. What is instantaneous current? We say 1 instant means okay, just 1 second or a fraction of second, maybe 1 nanosecond or microsecond, at an instant. So when this delta T is very small, we write I instantaneous. I instantaneous is equal to the change in charge will be very less. If charge is constant, I is equal to, if charge is constant, I is equal to Q by T. If charge is varying, but we are finding average current, Q2 minus Q1 by T2 minus T1. If you are finding for a very short duration, instantaneous current, then this delta T is very small. Obviously, this change in charge also will be very small. So we will write dq by dt, dq by dt. Now this I instantaneous is dq by dt. This can be solved using mathematically calculus. This we are going to study further in mathematics, just for understanding purpose. For solving the problems here in physics, I will just mention that formula also. Say for example, d by dt of t raised to n, this is the general formula for differentiating something, is equal to d by dt of t raised to n is equal to n t raised to n minus 1. This is the formula for differentiating a polynomial kind of functions. So using this formula we can solve if we get charge as a function of time, like q is equal to t square plus 1, something like that. If we get, we can find the instantaneous current. Say for example, if we need to find the instantaneous current at a t is equal to 1 second, and the equation for charge is given as t square plus 1, then we can differentiate using this equation. If we substitute this 1 second, we will get the value of current at that instant. What is this t square plus 1? When I say q is equal to 1 coulomb, q is equal to 2 coulomb, this is very clear. 1 coulomb of charge is coming or 2 coulomb of charge is coming. But if this charge that is coming is varying, if the charge is varying, on what basis it is varying? It is like if I write q is equal to t square plus 1. First second, 1 second if I put, the charge will be 1 plus 1, 2 coulomb. If I put 2 seconds, then 2 square plus 1, that is 5 coulomb. If third second, 3 seconds, 3 square plus 1, 10 coulomb. Likewise, based on time, charge is varying. So here t square plus 1, if I put some other variable like a distance, x square plus 1, that is not possible, that is not there here. Actually, conceptually we don't study that, but just for understanding purpose, mathematically I am telling, if x is distance and if we put x square plus 1, that means charge is varying with the distance. Charge is varying with the distance. If we put temperature here, with the temperature charge is varying. So when we say charge is a function of time, means charge is dependent on time. When I say charge is a function of time, mathematically it means charge is dependent on time. Charge is a function of temperature, if someone says, then it shows that charge is dependent on temperature. When temperature varies, charge varies. Likewise, that is what here it is. So I average is Q2 minus Q1 by T2 minus T1, or we can write I average is delta Q by delta T. If charge is constant, we can say I is equal to Q by T. And if we need to find instantaneous current, then I instantaneous is equal to dQ by dt. Then for differentiation, this is the mathematical formula for differentiating a polynomial t raised to n t raised to n minus 1. So this is the basics of current. Already we have studied this in 10th class. A little bit of mathematics also involved here. We will do some problems on this. So find the current through the conductor at a time t is equal to 2 seconds if the charge flowing through it varies with the time as q is equal to t square plus 5t plus 6. Okay. Pause the screen and try to solve this. Okay, so here what they are asking? They are asking the current through the conductor at t is equal to 2 seconds. So a particular instant is given here at a time t is equal to 2 seconds. So how we need to find the current? Instantaneous current, I instantaneous is nothing but dq by dt. So d by dt of t square plus 5t plus 6. Differentiating this, t raised to n, if we differentiate d by dt of t raised to n is nothing but n t raised to n minus 1. Okay, so same way here if we differentiate we will get 2t, 2 will come here, 2 minus 1, so that becomes 1. So 2t plus 5. Differentiation of constant will give us 0. D by dt of constant is equal to 0. Okay. So here now I instantaneous at what time? At a time t is equal to 2 seconds. So we have to substitute 2 for time plus 5. This is 4 plus 5 is equal to 9 ampere. So option B is the answer. We will do the next question from this topic. Number 2. Find the current. Find the current produced when a point charge q moves with angular velocity omega in circle of radius r. Options are omega by 2 pi, option B omega q by 2 pi, option C q by 2 pi, option D 2 pi by omega. So these are the options. Pause the screen and try to solve the question. So here a point charge is moving with the angular velocity omega in circle of radius r. So if this is r, it is moving like this. What is the current? So current I is equal to here q by t, because this is constant charge. A point charge is what? Moving around the circle. So I is equal to q by t. So what is the time taken? If it goes around full circle, the time taken is nothing but time period of time period in circular motion, time period t. So I is equal to q by t we can write. And this capital T, what is the formula for capital T? T is equal to 2 pi by omega. This we have studied this in first year circular motion also. We have studied this concept. If you have any doubt here, then you should watch the circular motion video and understand it. So time period T is equal to 2 pi by omega. So I can write I is equal to q by 2 pi by omega. Omega goes up, we will get I is equal to q omega by 2 pi. So option B is the answer. So solve this question, pause the screen and solve this question. Okay, so I'll write the answer. How to find I instantaneous? I instantaneous is dq by dt. I instantaneous is dq by dt is equal to d by dt of t square plus 4t plus 5. Differentiating this will get 2t plus 4. Now I instantaneous at a time 3 seconds. Substituting 3 here, we'll get what? 10 ampere. So this is the instantaneous current we get. Next question is I average. So how to find I average? Q2 minus Q1 by T2 minus T1. So this is equal to, what is Q2? Q2 is given as function of time. So here we will substitute the value of time here. 2 square plus 4 into 2 plus 5 . Note down this one first, then we'll write the other one. So I average is equal to Q2 minus Q1 by T2 minus T1. Q2 minus Q1 by T2 minus T1. So Q2 is Q is a function of time. So Q2 is nothing but the charge at time t is equal to 2 seconds. We will substitute that. 2 square plus 4 into 2 plus 5. So this is what is Q2 minus Q1, 0 seconds. So substituting that, we will get 0 square plus 4 into 0 plus 5 divided by T2 minus T1. So T2 is 2 minus 0. So simplifying this, what we get here, it is 4 plus 8, 12 plus 5, 17 minus 5 divided by 2. So 12 by 2 is equal to 6 ampere. So this is how we can find instantaneous value of current and average value of current from charge if we get. Now we found current from charge by differentiating if it is instantaneous current if we are finding. Now if we get current, then we can find charge also. So we will do some questions like that also. Now say I is equal to Q by T. So to find the charge, current into time, general equation. Suppose if we get a variable current, that is the current that is varying with the time, say if t square plus 1, something like that, then we cannot directly multiply this and get the answer, because this current here is not constant. If it is a constant value, say for example 2 ampere, for time duration t is equal to 2 seconds, then q is equal to 2 into 2, we get 4 coulomb directly. We will be able to write. Suppose if we get current as a function of time, just like a t square plus 1, something like this, then into 2, we won't get the answer there. This value of current varies with time. During such type of situation, again just like differentiation, we have to use calculus from max. Opposite of differentiation, we will have to use integration. So integration formulas I will mention, then we can do one question also. If we get a function like t square plus 1, or just I will write t raised to n, then if we differentiate this, when you integrate this, if you want to integrate a function t raised to n, then the formula is t raised to n plus 1 by n plus 1, and from time is a variable here, we are integrating with respect to time. So from what time to what time? Here it is from 2 seconds 3 seconds, then we will put that 2 to 3 here, substitute 3 here for n and minus 2. I will show you one example. If t square plus 1 second to 2 seconds, say for example charge is t square plus 1. If we need to find the total charge between 1 second to 2 seconds, we integrate. Actually this integration is nothing but summation, addition. Differentiation is nothing but taking difference. So integrating from 1 second to 2 seconds, t square plus 1 dt is equal to t raised to 3 by 3, just like a t raised to n plus 1 by n plus 1. Here n is 2. So t raised to 3 by 3 plus this 1 is here, this will become t, because 1 is nothing but 1 into t raised to 0. So when you integrate this, this will become 1 into t raised to 0 plus 1. So we will get t. That is why simply a constant, when you integrate, you will be getting t. Then putting the limits 1 to 2 is equal to 2 cube by 3 plus 2 minus 1 cube by 3 minus 1. So this is 1, this is another substitution. So the result of this is the answer. So this plus 2 students, the CBSE students, they will be studying integration and differentiation calculus after I think 4 chapters. After 4 chapters you will be studying this. Just for physics, this much we need as of now. So I have shown this. If you want to study this in detail, just to watch the video of mathematics calculus part of this to get more idea. Okay, now I'll come back to our current electricity problem based on this concept. Current is given, we need to find charge. So here it was like I is equal to dq by dt, this formula we have studied. dq is equal to I dt. This is the small charge that is passing at a time dt. The small charge I is equal to dq by dt. To find I instantaneous, so to find that charge, dq is equal to I dt. So here dq is nothing but the small charge, instantaneous charge that passing in the small time dt. Small charge that is passing at a time, small time dt. Now we need to find not that small charge at a small time dt. We need to find the total charge that is flowed through the cross section from 0 seconds to 3 seconds. So small charge plus the small charge plus for all those time instants, if we add, we will get that total charge that is passing from 0 to 3 seconds. So we have to add, right? So that many small instants we cannot add practically. So some genius have found this method for summation, that is called the integration. We just apply the formula and we will get the results. So Q is nothing but integration of I dt. This integration is nothing but summation from what to what? 0 to 3 seconds. Now 0 to 3 seconds, what is the function? T square plus 1. T square plus 1 dt. So t cube plus t, putting the limit 0 to 3. Substitute this 3 cube, sorry, here 3 will come, t cube by 3. 3 cube by 3 plus 3 minus 1 cube, sorry, here it is 0 by 3 minus 0. This will become 0. This 3, this will be cancelled. 3 square, 9 plus 3, this is going to be 12 coulomb. So 12 coulomb of charge will be flowing through the conductor. This question, okay, pause the video, copy the solution. So in the above question, the total charge that was flowing through the conductor is 12 coulomb. 12 coulomb. This is the total charge. If someone asks us like how many electrons would be passing, that will constitute a charge of 12 coulomb. How to find? In electrostatics, we have studied Q is equal to Ne, quantization concept. So using this we can find that also. So number of electrons N is equal to Q by E. This is 12 by 1.6 into 10 raised to minus 19. So the answer will be 7.5 into 10 raised to 19 number of electrons will constitute this much charge. So this is the concept related to electric current and charge, the first fundamental topic of current electricity. We will continue the remaining topics in the coming videos. Thank you, students.